Our last topic that we want to cover for um, rational expressions is complex fractions. A complex fraction will show up in our in our calculus problems as you move on, and in also other expressions that we'll be dealing with in this course. And a complex fraction is simply a quotient that itself has fractions. Okay, and there are two ways to do this, and I'm going to show you both. In some situations, one may be better unless you're specifically told which to use. It's your choice. Okay, the first method says the following. It says perform the operations in the numerator and denominator separately and then divide. Okay, remember that this fraction bar means division. But before we can divide, we want to have a single fraction in the numerator and denominator so that we can cancel. So let's see how we can do that. First of all, let's write that as 2 over 1 minus 3 over y, and 4 over 1 minus 9 over y squared. Okay? And then we're going to treat the numerator and denominator separately. What is the LCD of the numerator? I think it's pretty clear that it's going to just be y. So I just need to multiply the first fraction by y over y. And that's the advantage of putting that 1 there to begin with, because I can see that. In the denominator, what is the least common denominator? It looks like it's just going to be y squared. So I need to multiply by y squared over y squared in that first term. So when I do that, I get 2y over y minus 3 over y, and I get 4y squared over y squared minus 9 over y squared. And now I can combine into single fractions. Okay? And now I'm ready to actually perform the operation. So this means 2y minus 3 over y divided by, again, that fraction bar means division, 4y squared minus 9 over y squared. And of course, we know that we accomplish that division by multiplying by the reciprocal. Okay? And finally, then, we want to simplify and reduce. And we do that by factoring. We can't factor the first fraction, but we can factor that second denominator. It's the difference of squares. It's 2y squared minus 3 squared. Okay? And so that will factor as 2y minus 3 times 2y plus 3. Okay. And then we can cancel. And we're left with 1y here. So we get y over 2y plus 3. Notice that we have excluded values. Of y equals 0 and y equals 3 halves, because 2y minus 3 cannot be 0. So when you simplify that, we get those excluded values. Okay, that's the first method. So again, we actually perform the operation. We are going to divide, but before we divide, we write as single fractions by finding the least common denominator. Then we perform the division by inverting and multiplying, and then we simplify the result. Okay. There's another method that works very nicely and sometimes is actually easier to see. It's easier to work through, and that is to start with the original fractions and find the least common multiple of every denominator. So if I factor, as we always want to do that first, we look at all of these denominators. And what is the least common multiple? Okay, we have just two factors and they're raised to the first power at most in any one of the denominators. Okay, so that is our least common multiple. All right, so what do? We take our fraction, our original fractions, and we multiply each term by that least common multiple. Now I have to do that to each term in order to keep the fraction equivalent to what I started with. So you have to be sure to multiply each individual term by that least common multiple. And if you like, think of that as being over 1 if that's helpful. Okay, minus 2 over x plus 3 times x minus 3, x plus 3 over 1. Okay, now what does that do for us? Well, notice what it does. These will now cancel. So that whole numerator just becomes x plus 6. Okay, and in the denominator, the x minus 3's cancel, and I have x times x plus 3. And here, the x plus 3's cancel, so I'm left with 2 times x minus 3. And the advantage of that is that in one step, I have gone from a complex fraction to a simple fraction. And if I simplify that, I get x squared plus 3x. Now be careful, it's minus 2x plus 6 when I distribute. Multiply by negative 2, I get 2x plus 6. So that becomes x plus 6 over x squared plus x plus 6. And that is our final answer. Okay? It's a more efficient process than the one we saw in the first example. Okay, let's try it on this one. Now this is not a rational expression because we have square roots involved as part of our terms and part of our fractions. But this is an expression that we'll see in calculus, so we want to learn how to deal with it. And we do the same thing, okay? We still look at our denominators. And here again, think of that as x squared over 1. And if I look at all three of them, I see that the LCM is just the square root of x squared plus 1. X squared plus 1, sorry. Okay, so now I multiply each term by that LCM. And again, think of that as being over 1 if that helps. Now look at the second term. It's just the square root of x squared plus 1 times the square root of x squared plus 1. And again, if you like, think of those as both being over 1. This one, forgot to do in red. This is what I'm multiplying by. Okay. And in the denominator, I have my x squared over 1 times the square root of x squared plus 1. Again, if you like, think of it as being over 1. You don't need that. That's certainly only for your advantage. That's what I'm multiplying by. It's only if it makes it easier for you to see. Okay, now I can do my cancellation again, and notice what happens. I'm left just with x squared minus the product of the square root of x squared plus 1 times the square root of x squared plus 1 all over x squared times the square root of x squared plus 1. Okay? Now, what do we end up with? What happens when we multiply the square root of a times the square root of a? We know we just end up with a. And so that's what happens here. This is just going to be square root of x squared plus 1 times the square root of x squared plus 1. I multiply them together, and I just get x squared plus 1. And when I distribute that, I get minus x squared minus 1. And that's my result. Okay? And if we continue, notice we just get cancellation. We just get negative 1 over x squared times x squared plus 1. Okay? Now, in calculus, you would probably leave your result like this. But we can also take it one step further and rationalize. So it would just be up to the instructions that you were given whether you needed to rationalize or not. Let's go ahead for the additional practice and do that. Again, we'd like to get rid of that square root, so we're going to take advantage of this. And we're going to multiply it again by the same root. And again, I have to do that in the numerator as well. And so when I rationalize that denominator, my final result will be minus the square root of x squared plus 1 over x squared times x squared plus 1. And that would be the result if we rationalize the denominator. Okay, thank you.